Let's get into chapter 4, and we are going to solve systems of linear equations. For section 4.1, we are solving systems of linear equations in two variables. The pictures, the graphs that they start with just show us what it means. The solution is where they cross, if they do. So where they cross is this point right here. So when we solve for the two systems, well, for the system, I mean, the two lines would cross here. Two variables, that means an x and a y, they cross right here. If they do not cross, then we have no solution. And if it's the same line, infinite solutions. We'll get to that when we work some of the problems. Addition method and substitution method is what they start with in 4.1. Addition method means we add the two together, and our focus is to eliminate one variable and solve for the other. Then we plug that in and solve. So whatever it takes to get rid of one is our focus. Here, nothing matches up. A 4, a 2, a 3, a 1. So you can double this x and get a 4x, or you could triple the 3 and get 3y. So we either have to multiply through by a 2 or a 3 to get the numbers to match up. I followed the book's example. They started with a -3 to start out. So you multiply this one by a -3, and when we do, you can add everything together. You'll end up with 3 y's that are going to cancel out. So multiply this whole thing by 3 to make something cancel out, and you'll end up with x equals 1. Now, the other route is say, well, I don't want to get rid of y. I see a 4 and a 2. I'm just going to double this whole thing, and I'll get 4. Now, the key with addition depends on how you think of these. You can think subtraction, but I don't want to throw you off. If you're thinking addition, you always want these to be opposite of what you're trying to eliminate up here. So up here, we have a positive 3y, a positive y. We need to make this -3y's if we want y to go away. Here, to get rid of a positive 2x from a positive 4x, we will multiply through by -2 to get a -2x or -4x. So the key, increase the whole entire thing by whatever it takes to get rid of one variable. Okay, and then I did a lot of those examples. Now my cat's up here helping. Then we drop down. Well, I guess I should mention, there's the cat again. If we have a false statement, 0 equals 25, when you solve, if the variables go away, 10 minus 10x, 4y plus 4x, the y's, or the cat's really screwing with me. Our x's and y's go away, we're left with 0, but on the other side, we're left with 25. It's false. When it's false, there's no solution. The system is inconsistent. Now, example 5 tosses in a true statement that 0 equals 0. If you eliminate variables, but you have a true statement, look at this, -8 plus 8, -6 plus 6, -4 plus 4, 0 equals 0, true. Both are eliminated, but we have a true statement. That system is dependent. The solution sets all ordered pairs that satisfy each equation. And that's explained, I think, still on 250. I'll double check that. If any of you want to look, just look for dependent and inconsistent. Inconsistent, no solution. Dependent, infinite solutions. And then substitution method, you look for one that you can just make into the variable. Well, I should start up here. Make this y in the first equation. We have y, 1y equals this chunk. You can substitute it for y and solve that equation for x. Because you substitute that for y, it's no longer y, it's 3 times 3x minus 5. Okay, and we'll do a couple of these. Those were my notes. Let me work a couple examples. Now, some of these can take some time. When we get into the 3 variables, then we really need some time. All right, so I'm going to work number 10 first from section problem set 4.1. What I have is a negative x, negative y plus 2y. We could double this whole thing, but there's no need to. I have an x and an x. They're the same. What you can think, and I'll do it this way. You can think multiply everything through by -1 to make them opposite. Or in this case, the minute you see the same sign and the same leading coefficient, you can go ahead and say, you know what? I'm just going to subtract instead of add. I'm going to say x minus a minus x. That's the same thing as multiplying through. You make that opposite, it's negative x plus x. They go away. You make this opposite, it's negative 2y. So it's actually negative y minus 2y. You make this opposite, it's positive 3. So 4 minus a minus 3 is 7. So for number 10, we will divide by -3 and get y equals, whoops, we divided by a -3. I know that paper, it's not super easy to see on this. Let's leave it off, I guess. -7/3 for y. Now what you do is you pick either equation, doesn't matter which one, either equation, and say, okay, minus y. I discovered y is -3, or -7/3, 7/3, sorry. So I have negative x plus 7/3 equals 4. To solve this, I need to subtract 7/3. So I have a negative x equals, and now I have 4 minus 7/3. I need to make my 4 something out of thirds. Whenever you have a whole number, you just multiply it by the denominator. 4 times 3 is 12. That means I have 12/3 minus 7/3 equals 5/3, but I had a negative x. So to negate everything is -5/3. Your solution is -5/3 for x, -7/3 for y. And that's how number 10 is done. Now I wanted to jump to number 21. It's another addition, but it involves fractions. And there's different ways you can go about it. But if you want to, if you don't like fractions, I still suggest getting rid of the denominator. In this case, it turns into a big number at the end, but at least it's gone. My least common denominator for the first one is 6. So 1/2 x plus 1/3 y equals 13 is actually 3x plus 2y equals 81, because we multiply, or shoot, I don't know why I did 81. I'm losing it. 78. Gosh. So what we do is we get rid of the denominator, and we have to multiply through by the LCD. When we do, 2 goes into 6 3 times, so I have 3x. 3 goes into 6 2 times, we have 2y. Our denominator was 1, so we literally multiply 13 by 6, and we have 78. It's a big number, I know, but what it does is eliminates fractions if you don't like fractions. We'll do the same thing down here, and we have to multiply through by 20, sadly. Another big number. 5 goes into 24, and 4 times 2 is 8. 4 goes into 25, so 5y, and then 200. Now, this is a really, really nasty one, because now I have 78 and 200. I have 2, I have 5, I have 3, I have 8. There's no simple, quick way to get rid of these. If we use 8 and 3, we basically have to use 24 to multiply through. If we use 5 and 2, we have to use, we have to think 10. We have to change them both. So this is a nasty one. That's why I chose it. Now you could stick with the fractions. Keep in mind, you could always stick with the fractions. But let's see. I don't really want to multiply 78 by 8 and 200 by 3. I'm going to choose my 2 and my 5 because then I'm multiplying this whole thing by 5. I should have left room with my arrow. This one becomes 15x plus 10y, and then you got 78, and I still do this sometimes just to double check. So we have 390. It's a big number, but I'm hoping that the other big number will kind of make it a little easier. So we have 390. Now, what I have to do down here for addition, technically we're in addition, so I want to make it the opposite. So I need to multiply this by a -2 because I want to get 10 y's, but I want them to go away. In addition, we think opposite. It'd be the same line of thinking if we multiply through by a positive and then subtract, but the whole idea is understand the addition method. So I'm going to multiply by the opposite and then add everything together. That gives me -10y. And as you see, we've got some big nasty numbers, but I already see I have a -1 here. These are going to be gone. And 2 times 200 gives me -400. This is where the big numbers aren't so bad, because now what I really have is a -x. 15 minus 16 equals a -10. 390 minus 400. So x equals 10. That's quite a bit of work to get 1. We still have to go back and plug it in. Now, I'm going to choose to plug it into an original with a fraction, but you don't have to. You can plug it in. Well, no, you know what? Let's go ahead and plug it in. We'll plug it in here so we're not messing with fractions. I'm going to take this one. This is equivalent to this. So it doesn't matter. We have 4 options to plug 10. We could plug 10 in here, 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 or here. And no matter what we do, we will get the same y value. I'm going to plug it in here. So I have 3 times x. My x was 10. Plus, up here, 2y equals 78. So I have, I'll do it all the way. I have 30 plus 2y equals 78. Minus 30, I have 2y equals 48. And then I simply divide by 2. And I get y equals 24. So for number 21, I would write, and this was, remember, this was the answer for number 10, how we'd write the answer. The answer for number 21, x is 10, y is 24. There's our actual answer, the way we'll write it. Now, I'm going to do, I'll just do number 25 real quick. What happens is now we're into substitution. Keep in mind, you can always, well, here, I should have written it out. I didn't know how much room I would need. You don't actually have to do substitution. You can always keep doing addition. But in this case, they're trying to set it up to say, hey, look, we have 1x. Well, you know what? We had 1x here, we had 1y. We could have done substitution here. So substitution means you generally have a variable with a leading coefficient of 1. There's 1x. I know what x is. X is this quantity. Substitution says, okay, if that's x, then make that x. So for substitution, when you have a leading coefficient of 1 with your variable, you can just plug that in for that variable. And now what you're doing is you're setting up an equation in one variable and solving for it. So 2y plus 9. That's what my x became. There's a lot of arrows, sorry. 7x minus y equals 24. But down here it's saying, hey, check this out. X equals 2y plus 9. If I make x here equal 2y plus 9, then I've only got a y and I can solve. So I leave this y and I leave this 24. All I did was replace x with what they tell me x is. Then I distribute and I get 14y, and trying not to sneeze. Phew. Sorry. So I have, what do I have? 63, 14y plus, I have 14y plus 63 minus y equals 24. I have cat hair in my nose. So what I'm going to do now is, you can do all this at one time. I'm going to take my 63 away over here, but I'm at the same time, I'm going to take y away from 14. So I have 13y equals, and in this case, I have a negative 41. Whoops. Sorry, negative 39. I don't know what I was thinking there. I'm losing it. So I have a negative 39. When I divide by 13, I have y equals negative 3. They gave me x, but it was in terms of y. I substituted this for x, and then I solved for y. When you substitute, you eliminate a variable automatically by making it in terms of another variable. So y equals negative 3. It doesn't matter where you put it in. I'm just going to choose this one because we already have x equals. So it's easy enough to just plug my negative 3 in here and solve. And I don't have to move x anywhere or worry about dividing. So x equals negative 6 plus 9 equals 3. So my solution set, my actual solution for this, is 3, negative 3 for number 25. And that's the only other one that I wanted. That shows substitution. Keep in mind, if you don't like substitution, if you don't understand it, you can always take your x, move it here, subtract 2y, and have x minus 2y equals 9, and you can use addition. But substitution is real slick because you don't have to double, triple, worry about a negative, anything. You literally plug that in for the variable they say it equals. You can do it anytime you see a single variable in a solution that's 2 variables. Okay, I hope that helps with 4.1. It's going to get kind of time consuming after this. I'll do my best to speed them up a little bit.